Hello friends, welcome back to my YouTube channel named Electronics Engineering by Worship. Concept of virtual drone. For the op-amp, we know that gain is A is equal to V0 by Vd, and we also know that Vd is equal to V1 minus V2. So we can also write V1 minus V2 is equal to V0 by 8, right? And let us assume when gain is infinite, then then v1 minus v2 is equal to v0 upon infinite, and 1 upon infinite is 0. So v1 minus v2 is equal to 0. So we can also say that v1 is equal to v2. Since v1 is 0 is actual round, then v2 is also 0, but this is not actual round, which means it is the virtual round. Also, if v1 have any value k, then v2 have also value k. Now, inverting amplifier. The diagram is shown below. So, negative terminal is attached with the input Vi, right, having resistance R1. Current flow in is I1 with the feedback resistance RF with output V0, and positive terminal is having voltage VB, which is connected to ground, right? So, an op-amp circuit that produces amplified output signal that is 180 degree out of phase with input signal known as inverting amplifier. Since we know from concept of virtual round, when Vd is 0, then Va minus Vb is equal to 0, and we can also say Va is equal to Vb, but Vb is 0, so Va is 0. Now apply KCL at node A. So we can say I1 is equal to I2. So I1 would be Vi minus Va by R1 is equal to Va minus V0 by Rf. But Va is 0. So we can write Vi by R1 is equal to minus V0 by Rf. And we know Av is equal to V0 by Vi. So that is also equal to minus Rf by R1. So gain can be set to any value by manipulating the value of Rf and R1. The negative sign denotes a 180 degree phase shift between input and output. Non-inverting amplifier. The circuit diagram as shown below. As Vb positive have a input voltage Vi, and negative is connected to the ground with the resistance R1, having input current I1 with the feedback resistance Rf with input current I2, having output voltage V0. So an op-amp circuit is designed to provide a positive voltage, then the input is applied directly to a non-inverting terminal. From concept of virtual round, since Vd is 0, we can say Va minus Vb is 0. So we write Va is equal to Vb, but Vb is Vi, so Va is equal to Vi. Now apply KCL at node A. Since I1 is equal to I2, so 0 minus Va by R1 is equal to Va minus V0 by Rf, but Va is Vi, so we can write minus Vi by R1 is equal to Vi minus V0 by Rf. So we can write minus Vi by R1 is equal to Vi upon Rf minus V0 by Rf. Now get Vi common, so we can write V0 by Rf is equal to Vi by Rf plus Vi by R1. So we can also write V0 by Vi is equal to Rf by Rf plus Rf by R1. Since Rf by Rf would be 1, so we can write V0 by Vi is equal to 1 plus Rf by R1. And we know V0 by Vi is Av, so Av gain is equal to V0 by Vi is equal to 1 plus Rf by R1. Gain can be set to any value by manipulating the value of Rf and R1. The positive sign denote that input and output are in same phase. So at the end, thank you so much everyone, and please like, comment, share, and don't forget to subscribe to my channel and press the bell icon of the channel.